Hello, fifth graders. Today, our essential question is how do we multiply a decimal by a whole number? Our specific lesson is about multiplying a decimal by a whole number, and our learning objective is to multiply a decimal by a whole number. Now, we've been practicing multiplication with big numbers, and now we're just going to add a decimal point in. So let's look at a problem like this. If we have 9.8 or 9 8/10 times 2, copy this down in your notebook. We would take the 2 and we would distribute it by doing 2 times 8 and then 2 times 9. 2 times 8 is 16. We're going to carry the 1 above the 9. Then we do the 2 times 9, which is 18, and then we're going to add that 1, which is 19. Now, that's how we would do 98 times 2. But this time, we have a decimal point. So what do we do with the decimal point? Well, we're going to count how many digits are behind all of the decimal points. So I only see one decimal point here, so I'm going to count. I have one digit behind the decimal point. So I can take our decimal and move it over one time. So let's try a new one. If I have a problem like 67 hundredths, so 0.67 times 8, I'm going to do 8 times 7, which is 56, carry the 5. 8 times 6, which is 48, plus 5 is 53. And we're finished. But we look at the decimal point. How many digits do I have behind this decimal point? Well, I have one digit, and I have 2 digits. So, just as a reminder, I can tell myself I'm going to move my decimal 2 times, 1 and 2. So our final answer is 5 36 hundredths. Let's try this one. 34 times 53. And over here, we're going to write 34 times 5 3/10. And we're going to see how our answer changes. Well, either one, we're going to ignore the decimal at first. So let's start with the one on the left. 3 times 4 is 12. Then we do 3 times 3 is 9, plus this 1 is 10. Now we're finished with distributing the ones place, so we're going to cross those off. And we're going to put our placeholder in the ones place. Now we do 5 times 4, which is 20. The 0 comes here, carry the 2. 5 times 3 is 15, plus the 2 is 17. When we add those up, we get 1,802. So if we do the same thing over here, we're going to distribute the 3 and do 3 times 4, which is 12. Carry the 1. 3 times 3 is 9. Plus 1 is 10. We're finished with the 3. We're going to put our placeholder under the 2. Now we're going to go 5 times 4 is 20. Put the 0 here. Carry the 2. 5 times 3 is 15, plus 2 is 17. What do you notice? Well, every single digit is the same. But we're not finished with this problem because there's a decimal point. So we find our decimal point, we count how many digits are behind the decimal point. This time we have one digit behind the decimal point. So that's going to tell us how many times we want to move our decimal over to the left. And in this case, it is 1, which would give us a final answer of 180 2/10 versus 1,802. All right, now it is your turn. Let's look at 3 problems this time. We're going to start with just 46 times 3. Make that a little darker. 46 times 3, write this in your notebook. And give it some space, move it over. Right here, we're going to put 4.6 times 3. And then finally, we're going to do 46 hundredths times 3, 0.46 times 3. So all the same digits, which we learned a couple seconds ago that our digits and our answer should be the same. The only difference will be how many digits are behind the decimal point to tell us how many spots to move. So let's start with 46 times 3. 3 times 6 is 18. Carry the 1. 3 times 4 is 12. Plus 1 is 13. So we get 138. If we were to estimate this, I would do 46 is close to 50, and 3 can kind of stay 3. And if we do 50 times 3, that gets me 150, so I think 138 is pretty reasonable. Now this one, we're going to count our decimal spot. I got 1 digit behind the decimal, so I'm just going to draw this first as a reminder. So I would suggest that you guys do that first whenever you see the decimal in the multiplication problem. Just write it off to the side, and that's going to tell you how many times you got to move the decimal over. So if we do 3 times 6, that's 18. We carry the 1. 3 times 4 is 12, plus the 1 is 13. We get 138 again, but remember, we have 1 digit behind the decimal point. The decimal point always starts here. We move it over 1 time, and we get 13.8. Now, if we were to estimate 4.6, what would that be close to? Probably 5. If we do 5 times that 3, we're going to wind up with 15. 13.8 is pretty close to 15, so that's reasonable. Now over here, 0.46. Well, if I had to estimate that, I would say it would be really close to 0.5. If I did 0.5 times 3, we're still going to have to do decimal 1 spot here. We move it over. So I'm looking for an answer close to 1.5. 1.5. So let's see what happens. 3 times 6 is 18. Carry the 1. 3 times 4 is 12, plus the 1 is 13. We get 138 as our digits. But remember, 1, 2, that's 2 decimal spots we're going to be moving. So it goes 1 and it goes 2. And we get 1.38. What is 1.38 close to? I'm pretty happy with that.